Well, we gotta stop that. So the answer key, if you know where to find the practice test, the answer key is in the same place. So if you go to Canvas, hit Pages, and the list of all the home announcements, all that stuff, then there's a Pages link. It says Practice Test 3. I put the practice test in there, and the solutions are in there too. And I've got the video up that kind of isn't a video about the solutions, but it's a video about just thinking about the problems. Okay. So anybody have questions? Everybody know what's happening once lecture's over? You're like, yeah, I'm gonna go back to sleep. No, but then what's due tonight? It's gonna be quiz 6. And I will make it active on Canvas the minute lecture's over. And it'll be due tonight at 11:59 p.m. Please, don't try to turn it in 11:58 p.m. and technical difficulty. So, I mean, if you turn it at 12:05 a.m., I'm not gonna freaking take points off, but come on. Just get it done and go get sleep. Yeah. So any questions from that quiz? The quiz is on chapter 8. The formulas will be on the quiz. Anything from chapter 8? What was chapter 8 about? It's all melding together, Jeff. Who knows? I want somebody to say statistics. So chapter 8 was about confidence intervals. So like that's where we first learned about T-scores, right? Section 8.2. Okay. Let me make sure I got this set up right. Oops. Yes. Okay, good. All right. So not seeing any questions. We're going to jump right back into where we were then if there's no questions. Let me see. Let me pull this up here, get this thing ready. O'Reilly. All right. So now you should be able to see that sheet that we were working on before. All right, there we go. Okay. Right, remember this one? Remember this one about the coyotes? Yep, remember the coyotes? Good old coyotes, trying to let them live longer. Isn't that a nice, that's a good, noble thing. This is the one I did with my class yesterday. I put it up in the Canvas, so I had the option to draw stuff. I can't remember how it looked like when we were working on it. But we got to this point here. So if you kept good notes, you can remember we got that Z-score there. So let me catch us up to what we did, all right, especially if you weren't here last time. So the first step is, what are we talking about? So you write down the claim, right? So that you always capture the claim and then write it in mathish. So that's what we did here. The mean of our coyotes with more room, we thought it was more than normal, more than 10.15. Since that did not have an equal sign, we put it into H1. And then the other one is going to be the opposite of what we just wrote down. All right, let me stop there for a minute. Everybody remember that stuff? So the claim, for some reason people get mixed up about this, the claim can be either one of these. It's just that in this case, the claim did not have an equal sign, so I put it in for H1. Okay. H1 is the one that's going to set up what the rejection region is. H1, since it does not have an equal sign, it is the statement I can show evidence for. I can't take a sample and show evidence that something equals something. I can't, because I know the sample's never going to be equal to the right thing. I just know it. But a sample could be so far away from some preconceived idea that that idea must be wrong. Or at least it's really good evidence that the idea is wrong. Okay. So that's how we figured out it was a one-tail test up here. Because it's greater than, so I have to have a sample that shows up way the shit up there. Okay, hopefully nobody's got kids with them. You always gotta, if you have a kid with you, you hold them up to the camera. Oh, I got it, there's a kid. I gotta say Scheisse or something. If the kid knows German, let me know. I'm sorry, I stopped. So then part B is just, all right, before you start doing work, you got to know what you're allowed to use. Can I use something? And if I can use something, do I use Z or T, right? So that's part B. It makes sense. Part A is what the shit are you talking about? Part B is why you're allowed to do stats with it. And in this case, sample size big enough. I knew sigma, population standard deviation, so I don't have to use T-scores. Part C, now that I know I can do something, I set up this idea more formally. Where does that evidence start? How far away does that sample have to get so that it starts to be evidence that it's not here, it's actually up here? So we determined, since the alpha was 0.01, we determined in this case that unusual starts at 2.326. So before, when we first learned about unusual, we were using 2, because that is the standard, most common use of unusual. But these problems can change that definition, because sometimes it is worse to make a certain kind of error, right? So this is the weird part about this. And there's so many weird parts, right? So let me come back to that error idea. Part D. Now, so part C said, where does unusual start? Where does my sample have to go past to show evidence? So of course, part D is, did we find evidence? Go look at the sample. How far did it get? So we make a Z-score, right? I call it Z star. I don't know if I made a big deal out of that yesterday. I'm sorry, you know what I mean, Monday. Z star is what I call the Z-score that we get from the sample. And please, dear God, let me know if you have a question. There's a lot coming at you. Because there's a Z-score right there, right? And then I'm about to calculate another Z-score. So I just call it Z star to make it distinct. That's my Z-score. And then when I put it on the chart up here, when I put it in the rejection region, I can actually put a little star on it. Aw. So that blue line is where the Z star is. All right, so let me bring this all back together. Since that blue line, since the sample fell way the hell up here, whoever thinks that the actual mean is here looks to be wrong. If the actual mean was here, then it is much more likely that a sample I take would show up in here. Our sample showed up way out there. So therefore, it is more likely that this picture should be drawn further up. The picture maybe should look like this now, right? The mean is actually bigger. That would make this blue line less unlikely. Okay, let me get rid of that. That might be confusing later. Let me stop for a second. You guys doing all right? You're all like, dude, man, 7:30, pandemic, and we're talking about, I don't even know. Well, hopefully, I mean, most of this is a review, and I know it's still relatively fresh, but it's still stuff we've talked about before. So I desperately want this to make the most sense ever. I set up the bar. Here's exactly where evidence starts, and then part D is I look at the sample and I say, okay, did it make it? In this case, we did. We made it. So since the H naught is the guy who thinks it's in here somewhere, we can reject what he said. I don't remember, did I have these up here before? I can't remember. You guys are probably like, who knows? But yeah, if I make it, the reason this is called the rejection region is if our sample makes it in there, we can reject what this guy says, because he says, I think it's in here. And we got way the hell out there. Okay, there's really nothing more to it. One guy thinks it's in the middle. So if I get way far away from the middle, I can say it looks like that guy's wrong. So down here, right here, since we did make it way out there, we made it into the rejection region, I can reject the null, which means I can support the other guy, the high, right? If I think that one guy's wrong, that automatically means it looks like the other guy could be right. There's evidence he's right. Let me stop for a minute. There's a lot I just like put on you there. Let me know. Anybody have any concerns or questions about what we just said? I kind of like this. We just reviewed that problem we did. We did that problem last time. We just didn't finish it, so I want to finish it now. Finish him. So part E is, what the hell is your conclusion? The most important part. Oh, same formula as always. Do you guys see how the formula is my data point minus the middle divided by the spread? X bar minus the mean divided by the standard deviation, right? And there's the X bar, that's for my sample. And here's the big part of this. So let me explain the idea, and then I'll make it very short and easy to remember. We go into a hypothesis test assuming that this number is the right mean. We just go, assuming that's the right mean, assuming 10.15 is the mean. How the hell did we just do this? So it's sort of like what's called a proof by contradiction. Assuming that 10.15 is the right mean. Look where my sample went. It looks like 10.15 is not the right mean. That's why we can reject the null, because that's the one that thought the mean was 10.15. The short way to remember this is it's always my sample data minus the supposed middle. And the supposed middle will always be the number that's right up here. Assuming you wrote the right number there. All right. So it's the same old z-score formula. Same old z-score formula. Thank the gods, right? So my conclusion, how the hell do I write my conclusion? Did we make it? In this test, did our z-star make it past the unusual line? Did it make it into the rejection region? Yeah, we made it, right? We totally did. Look at us. We're way out there. Okay, so therefore, here's how I write the conclusion. We have found sufficient, oh Jesus, sufficient evidence. Jole macarones. We have found sufficient evidence to, okay. So that's step one. If we didn't make it into the region, we would say we have not found sufficient evidence, right? So that, again, that line we draw in this step, that line right there, the 2.326, that is where evidence starts. We made it, we found sufficient evidence. If that blue line wasn't in there, we would say we have not found sufficient evidence. That's crazy. To do what, Jeff? I don't know. You ready? Sorry. What was the claim? Which dude was the claim? The HO dude or the H1 dude? Which one was the claim? Which one? The claim is this one, right? Where did we put it? We put it into H1, right? Everybody with me? We put the claim into H1. Therefore, I want to use this language right there. Support H1. It kind of makes sense if somebody says, hey, you know some stats. I have a claim. Here's my claim. Blah. Go test it. And we go test it. When I come back to this guy, I want to be able to tell him, here's what your claim did. I have to talk about what the claim was. We have found sufficient evidence to, you can get back there, Jeff. Can you? Will it let me? Well, this is exciting. Let me back in. Everybody is hanging out. Screw it. I'll just start over again. We have found sufficient evidence to support the claim that, and now you ready, kids? Now you plagiarize. Just plagiarize the shit. Did I start recording? That would be really useful. Yes, I did, right? Oh, thank God. Which is bad too, because now my English professors, if you're watching this, I'm telling the students, this is the only place you can plagiarize. You have got to reference what the claim was. So let me go back up. What was the claim? That the northern mid-sided coyote lives longer in captivity if given more room to roam. All right, there you go. To support the claim that, why won't you let me back in? The northern Minnesota coyote, Jeebus, lives longer if given more room to roam. You can kind of paraphrase, that's fine. All right. Let me stop for a minute. Sorry about the different levels of that, but too bad. We have found sufficient evidence to support the claim that the northern Minnesota coyotes, you could do it, Jeff. It's just going to have to stay plural. That's just too bad. Lives longer if given more room to roam. So visually, do you see how that makes sense? Here's where the other coyotes are, right? Here's their average. Are you not going to, oh, I see. You're not going to let me do anything. I can't draw or shit. All right, give me a second, guys. Do, do, do. Do, do, do. Do, 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 do. There you go. Come back into this. Oh, shit. I don't want you guys to see that. Don't show everybody their grades. Stop it. Okay, thank God. Yeah, this is exciting. Where were you? Here. Sorry, everybody. Every now and again, you gotta like back out of Canvas so it lets me do this. Okay. All right, let me see. What point was I making? Who knows anymore? Blah, 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 blah. I've completely forgotten. I was about to do something. Shit. Too bad. Anyway. So here it is. Visually, here's, oh, that's right. Here's where it was. Can I draw? Hey, I can draw. Okay. That's where the 10.15 is, right? That's where the 10.15 is, right there. So do you see how visually this says exactly what we just said? Here's our blue line. That's for the sample of coyotes that were given more room, right? That blue line is the z-score for the sample of coyotes that was given more room to roam. Isn't that definitely bigger than this? I mean, not even just bigger, it is statistically significantly bigger. It's past this green bar. So it is so much above 10.15 that it's proof, it's not proof, it's evidence, not proof, that they do live longer. You can, that's the visual of what we just said. If that blue line, let me see if I can do this. If that blue line, you can do it, Jeff. If that blue line had been over here, ooh, that's so cool. If that blue line had been there, that's not evidence. I can't say it. It's not bigger than this enough. It's got to go past that line to be evidence, and it did. All right, I'm going to stop for a minute. How are you guys doing out there? Is anybody still paying attention to me? Like, still? Dude. Nobody. Okay, I'll keep going. So let me see. Let me come over to this one. So this one we started Monday. Okay, look at that. That's just so beautiful. I don't remember. I think we made it even to step C last time, but this is what I was doing with my other class. So if you were here Monday, this should look very familiar. This is the Ford Focus one. We visit a plant to see if their assembly time is the same. So that was the claim. So that's why I wrote mu equals 38. In fact, I could just put a U. I think we can get away from that, right? Just to make that a little bit nicer. Just pretend like that's it. I got an extra leg, so it's a mu. So the claim here is the mean is 38. That has an equal sign, so it goes in for H naught. Then the opposite of that is not equal to. That's what I put in the other guy. So it's pretty cool with that step. I mean, the very first thing you do is just an English step. Which sentence has the claim in it? Then you translate that to math. Then you say, does what I just wrote have an equal sign? I'll put it next to the null if it does. If it doesn't, I'll put it next to the H1. So the problem we just did a minute ago with the coyotes, we put the claim in H1 because it didn't have an equal sign. This one does, so I put it in HO. Not a big deal. You guys remember why this is a two-tail test? Two-tail. Totally a two-tailed test. Wow. What color is that? I like the dark blue. Anybody? This would be a good check to see who's still listening to me. Anybody listen to me? Do you remember why it was a two-tailed test? Two-tail. Anybody? Have you guys like put the ones I could see? Oh, okay, okay. Why was this one specifically a two-tail test? Because H1 is always the one I can show evidence for. How do I show evidence that something does not equal something else? I can show, yeah, more or less. That's all, that's it. It could be above or below. That's why it's a two-tailed test. The last one we did with the coyotes, it was greater than. It was only one direction, not the band. It was only one direction that would work, that would be evidence. This one, either direction works. So it's a two-tailed test. And now you see why the T-score chart is set up the way it is. Okay. Blah, blah, blah. It's great. It's great having a cold in the time of COVID. Scary to go to the grocery store. I think if I cough, they're going to like push me out of the store. Okay. Do we use Z-scores, T-scores, or nothing? I think we answered that one last time, but let's see if anybody paid attention. There's two things you have to tell me. And I'll tell you this right now. Sorry, Monica. The answer is not T-scores. What are the two skings, Jeff? The two things that you have to check. What tells me I can do something? What tells me I'm allowed to do something? What's got to be true for me to be able to do anything? What's the most important thing? Yeah. Why? How do I know it's normal enough? It doesn't say it is. It doesn't say it's normal enough. Yes, okay, so n equals 71 greater than 30, right? Kick ass. That's the central limit theorem step, right? Saying, why is it normal enough? Because the sample size is big enough. Now, what do I look at to tell between T and Z? Yes, I know the population standard deviation known, so I can use Z-scores. So again, why were T-scores invented? Why were T-scores invented? Because some dude got too drunk off of Guinness. No, T-scores were invented for when I don't know the population standard deviation. They cover my ass for not knowing that. I know it here. I don't need them. Thanks, T-scores, I'm good. You guys smell of alcohol anyway. Okay, so I don't know if you guys remember that about Guinness. Oh, too bad. All right. So let me put some stuff down here, see if you guys can do this. So I know it's a two-tailed test. I know alpha is 0.05. I tell you right there, right? And I know I can use Z-scores. Don't write anything in the chat. Can you figure out what the Z-scores are?
Professor?
Yes, ma'am.
I just have a question.
Yes.
In general. So I think I'm still confused on the T versus Z scores. And I thought you said, so when you don't know the population standard deviation, you would use T scores?
Yes.
So that's not the sigma though, right?
Sigma is the population standard deviation, yes.
So in this case, sigma is known, right?
Yeah, it's
so
right
then
there.
that's why you use Z score.
Yes.
Okay. So
like
sigma is the population standard deviation. Okay. I think that
Greek letters, population. Right. Mu is population mean, X bar sample mean. It's just a poor little non-Greek letter. All right, let me see if I can move this guy up. All right. So it's a two-tailed test. Alpha is 0.05. And I did talk to you guys about, this is a Z-score problem, right? I could use Z-scores. We just determined that. So I'm going to look at my T-score chart to find them. Is anybody worried about my mental stability? Not in general, but because I'm going to use a T-score chart to find the Z-scores. And you're like, dude, I'm worried about my own mental stability. All right, I understand. So remember, guys, if you're out there, I know a couple of you are. Oh, somebody is coming back in. At the bottom, so again, I can't remember if I said this to you guys. As the sample size gets bigger and bigger and bigger, do you see how the t-scores get smaller and smaller and smaller? Because t-scores were invented to cover my ass from when I don't know sigma, but the larger my sample gets, the more I trust S. The closer S gets to being true, being the real population standard deviation. So the bigger the sample gets, the less I need the t-scores until my sample gets, holy crap, my sample gets so large that I can just go ahead and use t-scores. There's the t-scores at the bottom of the chart, right? So hell yeah, I'm going to use this thing. It's beautifully set up for hypothesis tests. One tail test, two tail test. So here I have a two tail test. Alpha is 0.05. If I stop, I get a t-score. But if I go all the way to the bottom, I get a z-score, 1.96. Oh shit, I need more room. Get up there. Okay. Okay. Color this in. Let me do it. All right. That is my rejection region. That's in two places because it could be up or down. Because we just think it's not, the H1 thinks it's not equal to. So how do I say this in words? You just say it. I'm going to let you guys do the next problem without me. If Z star, if the Z-score I calculate, if my sample Z-score is less than negative 1.96 or greater than 1.96, no, Jeff. There you go, buddy. Right? I know you get lost in the details. I know. But if we're just so freaking far away from the middle, it looks like what we thought the middle was is wrong. That's really what I'm saying right now. So I want to be more detailed. What does it mean to be far away? In this case, up 1.96 steps or down 1.96 steps. Once you're more than that, you are far away. That's the definition of far away for this problem. So if my sample does show up less than negative 1.96 standard deviations or more than 1.96 standard deviations from the middle, it looks like I can say the middle is wrong. It's in the wrong place. It looks like the HO dude is wrong. So there, right there, if that's true, if Z star is way the hell out there, I can reject the null. I can support the high. Well, it's H1 really, but oh. I know. So again, I really want you guys to get this. HO is the dude who thinks it's in here, right? He's the guy that thinks it's equal to 38. So he thinks it's around 38. How do I show he's wrong then? By getting so far away from 38. I think the average age is 38. Well, I just talked to them. The average age is 50. You're full of shit, right? That's basically what's going on here. So where is far enough away? 1.96, up or down? That's almost our standard definition. Remember, it's unusual you start at 2 standard deviations. This is almost back to normal here for this specific problem. Okay. Let me see. I want to finish this one up and then let you guys do the other side. So the sample information, what do we know from the sample? So what's X bar from the sample? Looks to be 37.3. And then we know that N was 71. We know that, get in there, sigma, Jeff, was, what was it, 2.25? Is that right? Yes. this sucks that I can't make these symbols, but now we know that the new sigma, is everybody with me? The sigma sub x bar, let me see if I can draw the symbol. The sigma x bar. No, you can stop doing that now, Jeff. Okay. Which equaled the sigma divided by the square root of n. This should be very, very, very familiar to us. No, not awkward. That's awkward. Right? I'm just going to take sigma divided by square root of n. Remember doing that shit? When do we do that shit? When I take a sample and I'm talking about x bar. It's exactly what we're doing in every hypothesis test for a mean. That's exactly what we'd be doing. So we have to do this step. So it'll be 2.25 divided by the square root of 71. And then whatever the hell that is. I got it. Anybody got that? Yes. So make sure you get that. I mean, hopefully that's, so the thing about these kind of problems, in fact, in all of mathematics, the minute you get a problem that's got more than 2 steps to it, students kind of freak out. And I think partially it's because you try to have every step in your head at the same time or something crazy. This step is just make a z-score. That's all step D is. So I got to know what my x bar is. And then I got to change the standard deviation just like we did before, right? And so I get 0.267. And then the formula for the z-score is the same. It is the same as always. The formula for the z-score, I call it z star, of course, is our data, which is 37.3, right? That was our x bar, minus the supposed middle, which is 38. We're going to assume that's the middle, divided by the new standard deviation we just did. That's the same old z-score formula. That's the thing you got to remember and realize is what parts of the problem are old news. This whole problem, there's very little new in the problem itself. There's the idea of hypotheses and that kind of thing, but the actual work is not new. It's just packaged a little differently, but this is definitely not new. We've done this many times. So Z star, let me see what I get. What am I going to get? I'm going to get, oh, screw it, Jeff. No, I'm not feeling like I could do that in my head today. Yeah, negative 2.62, I agree. Negative 2.62. What just happened? What happened to you? Oh, I see what it did. Okay. Let me circle that bad boy. Wow. You don't have to do those. So again, I kind of hate that I did this. I should have made this so that it didn't work, but where did we fall? Let me put this in red. Put that number we just found on the picture. Negative 262 is down there. Let me make a star. Let me make it. Get out of the way. Let me make it. There we go. Okay. Right? So again, you got to be careful. You got to realize it's a number line. You got to put the thing in the right place or else none of this is going to make any sense. And you're like, when do we need to use score to find score? I'm not sure what you mean. When do we need to use? You mean this formula that I just used? Or this chart? I'm not, Sirikon, what do you mean? Sorry.
I mean, when do we know that we have to use t-score to find z?
Oh!
I'm sorry,
Oh.
my typo.
All right, wait a minute. Let me make sure I really understand. When are you talking about the t-score chart, or when do we know when to use t-scores instead of?
Like we get minus 1.96 and 1.96, and thus you use t-score to find z-score, right?
And again, it's because on the t-score chart, there are z-scores that live at the bottom. So it's almost too nice to believe. I can use this t-score chart to find z-scores because they live at the bottom. And why is that so kick-ass? because hypothesis tests can be one or two tail. And this is set up beautifully for one or two tail situations.
But can you use Z-score?
The Z-score chart?
Chart?
Of course. Yeah. Real quick, if you want to see that in action, up here, look at how much area is in that tail right there? It must be 0.025, right? Cut that in half. Is that cool?
Yeah.
And then if you look up 0.025 in the Z-score chart, you'll get -196. The same way we just did. It's just a shortcut to use the T-score chart.
Wow.
Yeah, the old stuff that we did before has to still work. We're just getting more charts and more shortcuts for certain situations. I like it. So, let me change this to red so it matches. There we go. Look at that shit. Yeah, Jeff. All right. Okay, now. So did we make it? So again, H naught, this guy. Let me see what color I want to put him in. Let's put him in yellow. Can you guys see yellow? Oh my God, can I draw? Well, that's a known. That's a no, Jeff. This guy thinks that it equals 38. So he thinks it's in the middle. He thinks it's in here. Oh no! Oh, this sucks a lot. All right, let me put him back. Okay. He thinks, just let me draw. He thinks it's in, no! Oh, screw it. So he thinks it's in the middle. Can't do it. He thinks it's in the middle. So if we get way out in the rejection region, we can say he's wrong. We can say that's evidence that the guy who thought it was in here is wrong. So right here, I could say, let's see if I can say it. Reject, can I say it? Let me say it. Reject H naught. And at the same time, we can say support H1. I don't know why one of them is. Just, it's okay, Jeff. All right, I'm sorry. Stop it. Oh, sure, that's fine. All right. Oh, okay. Playing around with this thing. So I desperately want you guys to see it's really just the heart of a hypothesis test is where's the evidence start? Make the sample into a Z-score and see if you found evidence. So we did. We got past the bar that was evidence. So then I can reject the one, the HO, and I can support the H1. I just said the same thing twice. If I think this guy's wrong, I think this guy's right. Those are the same thing I just said. Now help me out. Here we go. Here comes the conclusion. Did we make it? Yes. So I don't say we have failed. I say we have found sufficient evidence to do what? Well, what was the claim? Which one was the claim? Was the claim HO or H1? Which one was the claim? You can see it, right? You can see what the claim was. Not sup. Not sup? What did I do? Not support. Oh, not support. True. We're going to reject. So the claim, do you see how I put it in for HO? So I need to use this language here. No, get out of my way. This thing is nice and horrible at the same time. I want to use that language there. All right, that's the part that's going to take some getting used to. But everybody's always like, how the hell do I word the conclusion, Jeff? Do I say support, reject? How do I know? Because you always want to word the conclusion based on what the claim was. The claim was the null, so I used this language. We have not found sufficient evidence to reject the claim. The claim that, I forgot now, what was it? That the assembly time at this plant is the same as the overall average. That the assembly time at that plant is the same as the overall average. Yeah. And that makes sense. If it was the same, it should have shown up in here. It should have shown up close to 38. It didn't show up anywhere near 38. That's evidence that it's not the same. I can reject that it's the same. I can feel your love for these problems coming through somehow. It's weird. I didn't know that my internet service provider did that for me, but he does. I want you guys to try out as much as you can on number 2, on the reverse side. So try that out. I'll sit here. Let me know if you have a question. Oh, I'm going to check in with you guys in a minute. Oh, I can do this. Let me see. Ba, 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 ba. And by the way, guys, at some point, there's a way I can break you guys out into groups. Unfortunately, I didn't make sure that you guys could either see this or print it out or something. I'd really love to like sometimes break you up. You get your own little room with like 2 other people and you could discuss a problem with each other. Does that sound absolutely terrifying to anybody if I did that? Joanna says slash. Oh, it sounds terrifying? Is that what you mean? Okay, I'm sorry. Oh, it's actually kind of nifty, but we don't have to do that. Maybe should I pause? No, screw it, I'm not gonna pause. Let me check in with you guys real quick. Which sentence has the claim in it? First, second, third, or fourth? Not the word claim, but which one has the actual claim? Yeah, the second one has the actual claim in it, right? There's certain keywords. Claim is normally a big one. Feel, believe, stuff like that. That's somebody's claim. We think this is true. We feel this is true. We believe this is true. That's going to be a claim. So we believe the debt has decreased. So now you just have to write that in mathish. The average debt has decreased from what? Let me write it. Let me do 2 things. I'm going to write it in English. Holy crap, that's a big ass. Let me see. Boop. Shove it. So what's that look like in, well, let me do that. What's that look like in mathish? Jeff, I swear to God. Can I please? There's a little arrow. Okay. So in mathish, that looks like the average debt Decreased from what? What number goes there? We think it's less than what? Beautiful. What number would never show up in part A is 880.34, right? $880.34. That would never show up part A because that's the sample stuff. That doesn't show up until the fourth step. So I have to have an idea before I take a sample. So we think that the mean is less than 906. Keep going. What time is it? All right. What time do we go till? 8? We go until like noon? No, we go until, we got about 15 more minutes. Okay. I'm not frozen, am I? Hey, real quick, can somebody hear me right now? Anybody? Yes, okay, good. I think some other people, at least one other person is frozen. I couldn't tell if it was me or them. Thank you. Oh, yep, she just got kicked out. Let's see. Oh, she's still there. Okay, good. Oh, yeah. Okay, let me check back in. Where will the claim go? In HO or H1? Hey, Quincy. Oh, I know. Sorry, it's a dumb joke. Definitely into H1 because why? Because, Jeff, it's just the way it is, boy. Get used to it. No equal. Doesn't have an equal sign. There, that's it. That's it. So then what's the other one going to be? Whatever the other one is, whatever you left blank has to be the opposite. So, of course, that one's going to be, what's the opposite of less than? Don't say greater than. It's not quite right. The opposite of less than is greater than or equal to. I like it. Jeff, you can do it. There you go, buddy. So that's a greater than or equal to sign. Just deal with it. It's the way it's got to look. So how many tail tests will this be? Look at H1. Where would evidence have to show up? Could it show up on either side? Yeah, it's got to be a one-tailed test. That's right, because evidence has got to show up below 906. It's a one-tailed test. It's a directional thing. There's a direction to it. Let me keep the color thing consistent. So it's going to look like this. Wow. Less than. So it's going to be down here. For some reason, I get people put it on the wrong side. The arrow's pointing that way, so I'm going to put it down, down. All right, try to keep going. This one's a little bit different. We finally get something different on the one that we have to do by ourselves, Jeff. Really? What the shit? Oh, well. Yeah, Olivia just gave it away. Why do we have to use T-scores? Why am I allowed to do something? Let's start there. Same old thing, right? It's like, man, how many times we got to say this, Jeff? The n is greater than 30. No, Jeff. Holy macaroni. And then what tells me, so I know I can do something. The thing that tells me I have to use a t-score is the fact that, now this is where people get really confused. I get people say, we know the freaking standard deviation, Jeff. We know the standard. Of course we know a standard deviation. We have to know a standard deviation. Which standard deviation do you know is the key? The standard deviation that they tell me came from the sample. Do you guys see that? You have to do a little bit like the barest bit of detective work and go, from a sample of 81, we find these, oh shit, that standard deviation is a sample standard deviation. I can't use z-scores. You actually have to, just take a minute and think that way. So we have to use t-scores. Get in there. Sigma unknown. Get out of there. Only know S. Kabam. So now I know I got to use t-score. So now try to do part C. Let me point out to you that you need to know this little piece of information right there, way up there, the alpha. You know it's a one-tail test. You can figure out what the degrees of freedom are. Don't type into the chat yet. Don't do that yet. Try to figure out what the t-score will be. Please, dear God, let me know if you have a question. I mean, don't just sit there saying, well, I'm going to suck at this. No, come on. Maybe there won't be too many of these. And the whole next quiz after today's quiz will be about this. You don't want to fail that bad boy. You don't want to fail it. Oh, man. Whoa. Oh, I'm just going to erase that. Pretend like that didn't happen. What is going on, Jeff? All right. That's all right. Fine. Sure. Fine. Whatever. There's one thing you got to be careful about. Has anybody got that t-score yet? Let me see if you put it down right. Nobody got it? Maybe. I haven't even looked it up yet. So let's see. Degrees of freedom 80. So I know alpha is 0.01. So I also should put down here, it's a one-tail test. One-tail test. Alpha is 0.01. So I'm looking up here. See, one-tail test. Alpha is 0.01. So I'm in the second column. And I want to stop at 80. I can't do it that way. So try again, I think. What'd you say? 475. Why would you think that? I'm not sure. So it's 2374. Yes, 2374. Exactly. Almost. That's not quite right. It's so close. So close. Thanks for playing. What's wrong with it? Look at the picture. Where is it? It's down here. So what should it be? Negative. Yeah, we're the humans, right? So notice how this chart has no negatives on it? Because why would it? Why should it? We should recognize when it's negative. When it's below the mean, it's going to be negative. That's why the chart doesn't have negatives on it. It doesn't need to. So let me see. Let me fill that in. Here's my rejection region. Let me see if it'll let me do it. I'm going to get in there. Okay. So if I say this in words, now let's see if you guys are cool with this. If my T star, right, it's got to be T scores. If my T star is less than negative 2.374, so what that says is if I get into the rejection region, what do? I reject the hoe. I support the high. Let that make sense. That's why we call it the rejection region. If I get in there, I can reject the null hypothesis. If I don't, I fail to reject the null hypothesis. So let me do this for you. Let me put down here step D. Let me summarize the stuff we know. X bar was, oh, come on. X bar was 880.34. I don't know if you guys are like, oh, that's pretty good, or oh shit, I'm way above that. I don't know. My grad school year was very plastic, I like to say. I had a big old credit card debt to pay off. Let me see. 106.25, yeah, okay. N is 81, and here's the step that people really don't understand. So everybody cool with that? All I did there was summarize the data, right? I just summarized what they told me. The sample mean was 880.34, the standard deviation was 106.25, and N is 81. Here's the step that really screws people over. I still need to find the new standard deviation. I do. Of course I do. This standard deviation is for individuals. This is for individuals in that sample. I need the one that works for groups of 81. I still have to change it. People all get confused. They're like, it's already a sample standard. That's not what the thing does. That's not what dividing by the square root of n does. It changes it into a spread of groups. That's what it does. So I still have to find the new S. So it's going to be the old S, 106.25, divided by the square root of 81, divided by 9. So what's that going to be, Jeff? 11.64. I don't know. Is that right? It sounds right to me. Let's see. Or close. I'm saying that's close. Ah, damn. I was hoping I'd be closer than that, but too bad. Maybe some of you guys are still impressed. 11.806. I'm bummed out. What did I do? Oh, no, I don't know. Why we have to change again? What do you mean? Oh, so again. All right, listen. Sigma and S are both standard deviations of individuals, right? The 106.25 is what we calculated within the sample of 81 individual students. I need now a spread of groups of 81. I can't use the one that's for individuals. I need to make the one that's for groups of 81, which is what dividing by the square root of n does. I don't care if it's sigma. I don't care if it's S. S is an estimate for sigma, so they are the same thing. Just S is an estimate. They are both individual spreads. So no matter which one I got, I need to change it to the one that works for groups, and that's how we do it right there. So I know that's weird, but it kind of points out to me that nobody really kind of understands it in the first place, but it's freaky, I understand. And now we just make, and thankfully, this is where you guys really, I hope to God, I very often use Z and T interchangeably because really they mean the same damn thing. So thank God the T star formula, it's the same frickin' formula. It's the same formula. It's going to be my data, right? Let me put this in parentheses. My data minus the supposed middle, which again was 906. I get that from up here. The supposed middle divided by, oh my gosh. Okay, divided by the new spread, 11.806. So let's see what we get. What am I going to guess? I'm going to guess 2.4 or something. I don't know. I'm not feeling it today. Oh shit. I didn't want to do that. Yeah, I'm still in there. What did I say? Nah, screw it. Forget what I said. What do you guys, anybody get that? Yeah, I get negative 2.17. Yep. Oh, finally. Oh, we finally get new and all kinds of counts. So up on the picture, where does that fall? Up on the picture, where does it fall? What was that, Jeff? That's a Christmas song. But shit. In the picture, where does it fall? Did I get in here? 2.17 negative? No. Oh yeah, it's the first time we failed. We suck. I want that to be blue. We don't suck. It's just a part of, it's just how it works. So let me see if it'll let me do this. Get out of my way. That's right. That's right. That's right. All right. Did we see that? So negative 2.17 did not quite make it. Did we find evidence that H1 looks right? No. We didn't find evidence. We didn't make it. So right here, I can say this. From the picture, I can see we didn't quite make it. So I fail to reject the null. Which also means at the same time, I fail. You can do it. Come on. Just catch up to me. Fail to support. Support H1. Oh, boy. That is disgusting. We didn't make it. So right here in words, if we made it, I could do these things. We didn't make it. I fail to do those things. So the conclusion, this is going to be nice. We didn't make it. So we have not, we have not found. Fopind? My God. I type as well as I write. So we have not found sufficient evidence. Yeah, come on. Now which one? So again, before I finish that sentence, which one was the claim? I'm going a few minutes over. I'm sorry, everybody, but which one was the claim? The claim was less than. The claim is H1. So I want to use this language. Fail to support the claim. We have not found, that's fail, sufficient evidence to support the claim that mean student debt, what was the claim? Oh yeah, has decreased. Bam. Done. And then I go write up a little article and put it in there, blah, blah, blah. It's been clinically proven. In fact, that phrase clinically proven doesn't mean proof. This is clinically proven within a statistical significance. All right. I think that's enough for today. I've gone over time, I believe. So what I'm going to do, so we have the quiz. I'm going to make that active. So you want to go get that sucker, get it done, get it over with so you can go to sleep at a reasonable time. I posted the video for the front side of the practice test. And again, it's not a solutions video. I'm going to do the same kind of thing for the back side, which is going to be what the quiz next Wednesday is going to be on. The quiz next Wednesday is, what did it say? The next quiz will be on chapter 9. I think I probably will make chapter 10 extra credit. I'll tell you for sure later. Okay, any questions, anybody? Anybody need to hang out for a bit? I'm gonna stop sharing so I can see everybody. There's everybody. Anybody need to hang out, or are we all good?
I have a question.
Yes.
About the last one. The tail was on the left side. Was it because the claim was less than the mean?
Yeah. So H1
Yeah.
is the statement I can show evidence for. So it is the one that sets up what the rejection region is going to look like. That's less than, so it's going to be down.
Okay.
Yep. Kick ass. Anybody else? Everybody else is just like, I don't want to miss if there's a good question. All right. I'm not seeing any more questions. I'm going to shut things down and get ready for my next crazy ass Zoom meeting. What a life. All right, guys. Take care. Good to see you.